talk about exponents. So let's say that you have 3 squared. This number is going to be the base, and this number is going to be the exponent. Basically, the exponent is telling the base, hey, duplicate for me 2 times. So the base goes, okay, 3 times 3. So 3 squared is the same as 3 times 3, which is equals to 9. Let's say that you have 3 to the 4. Again, I'm going to ask the exponent, hey, how many times do you want me to duplicate? The exponent says 4 times. 3 times 3 times 3 times 3 is equals to 81. So this is the basic of exponents. Basically what we're doing here is, understanding that when you have something elevated to an exponent is how many times this, this base is going to duplicate. So let's start with some basic rules. So for example, let's not put a number, let's put a letter. So a to the 5th times a to the 6th times a to the 3. Well, this guy is duplicating 5 times, 6 times, and 3 times. We do not want to multiply this. We want to add them because remember, this is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and then 1, 2, 3. And then this is just going to be 5 plus 6 plus 3, which is going to be equals to a to the 14. Or if you do it like I tell my students manually, you will get 14 A's. So this is basically the meaning when you have the same base. Now, let's say that you have something like this. So let's say that you have 3 squared, this elevated to the 4th. Now here, we gotta be careful because we have something elevated to something else. So instead of adding, what you're going to do is multiply, and I'm going to explain you why. So this is going to be equals to 2 times 4, which is equals to 3 to the 8th. It makes sense because this guy is asking the exponent, hey, how many times do you want me to multiply? And then he's saying 4 times. So that's basically what we're doing. If you think about it, all what I'm doing is doing 2, 4, 6, 8, and that's how you get 3 to the 8th. So when you have multiplication, when you have, a parenthesis, you're going to multiply when you have them like this. So let's just recap really quick. For example, if I have a squared times a cubed, this is a to the 5th. However, if I have x squared to the cube, this is a to the 6th. Very important. Take a little screenshot of that because believe me, this is what's going to help you be successful when you do algebra, which you're going to see a lot of letters, but we're going to have fun with that. We'll get there. Okay, so we already figured out how, let's say that now you have something like a fraction. So let's say that you have 3 over 2, and then this is elevated to the 3rd, okay? So what I'm going to do is that every single term is going to be affected. So this is going to be 3 cubed over 2 cubed. And then this will be 27 over 2 times 2 times 2, which is equals to 8. Do not make the mistake of saying 2 times 3, 6, 3 to the 3, 9. Do not do that. Because remember, this guy is telling the base, hey, go 3 times 3 times 3, and 2 times 2 times 2. Let's say now that you have a negative exponent. So what happens when we have a negative exponent? Let's think. Well, if I have a to the negative 1, what I want to do is to find the inverse. So this is going to be 1 over a. Now, this a has a 1 that is right here. We don't put the 1 because we know that the 1 is there. But I tell students, if it helps you to put the 1 just at the beginning, just to visualize it, just do it. It's not incorrect. It just basically looks like, sometimes the teacher might feel like, but that does not mean that it's incorrect. It's completely correct. So if I have a to the negative 2, this is 1 over a squared. Now let's say that you have negative 2 to the negative 5th. Be very careful here because look, this negative belongs to the 2, not to the exponent. So I will still bring this guy to the bottom, right? But my negative belongs to the whole thing. So this will be 1 over 2 to the 5th. So let's do another example. Negative 3 squared to the negative 2. Then look what's going to happen here. This is going to be negative 1 over 3 squared. Think of this. This is only affecting this, not the negative. Now, let's see what happens when you have something like this. So let's say that you have minus 3 squared and negative 3 squared. This is very important because look at the difference between A and B. A is just having this negative here hanging out with it, but that doesn't mean that, they're together. So this is going to be 3 squared, which is equals to 9, but the negative was there and no one touched it. However, here the negative 3 is trapped. That's the reason why this is going to be negative 3 times negative 3, which is equals to positive 9. Be very, very careful with this, okay? Finally, let's just do one other example of when you have exponents. So let's say that you have a to the third, right, plus a squared. This is not a to the fifth. Notice here I'm adding. It's completely different, right? You cannot do this. You cannot say, okay, you cannot do that. I'm going to just scratch so you don't even think about it. You can only apply these rules if you are multiplying. So what does that mean? Let's just do it again. If you have a square, like for example, a squared, a to the fifth, this is a to the seventh. But if you have a squared elevated to the fifth, this is equals to a to the 10. Finally, if you have 1 over, let's say a to the negative 2, then this guy will come up positive like this. Or if you have a to the negative 2, then you just bring it down and it becomes positive. Thank you so much, and I'll see you in the next video.